Okay, since we know how to get standard error, and we know now that we use the t-distribution for the confidence interval, we'll also use it for finding the p-value. We're going to go ahead and do a hypothesis test. So men hoping to have children are encouraged to avoid hot tubs or saunas because heating the scrotum by just 1 degree Celsius can reduce sperm count and sperm quality. A new study indicates that men might want to avoid using a laptop computer on their lap for long periods of time. In the study, 29 men sat for an hour with a laptop computer on their lap. Mean temperature increase was 2.31 degrees Celsius with a standard deviation of 0.96. Okay, so that's one number we need. That's another number, and we need the sample size. Test to see if we can conclude that the average temperature increase for a man with a laptop computer on his lap for an hour is above the danger threshold of 1 degree Celsius. And show all the details. So conditions, well, our sample size is barely less than 30 at 29. And it doesn't really give us the data, so we can do a dot plot to see if there are any, to see if it's symmetric or if there are any outliers. But we're going to assume that it's symmetric. Our null hypothesis is that the mean is equal to 1, because that's what it wants us to check. Is it above the danger threshold of 1? So our alternative is that the mean is going to be greater than 1. A mean is the mean scrotal temperature or scrotal temperature increase for all men who sit with a laptop on their lap for an hour. Okay, so now we need to find the test statistic. So T, because we're working with a mean, is the statistic minus the null over the standard error. So our statistic is at 2.31. Well, first we have x bar minus mu over s divided by square root of n. So we have 2.31 minus 1 over 0.96 divided by square root of 29. And this gives us 1.31 over 0.96 divided by square root of 29 is 0.178. And 1.31 divided by 0.178 gives us 7.35955. 7.3596. So this is the number we're going to use to find our p-value. So for the p-value, this is a right tail because it's greater than. So we're doing TCDF. Since it's a greater than, 7.3596 is our lower limit. 999 is our upper limit. Degrees of freedom is the sample size minus 1. So degrees of freedom is 28. So second vars, TCDF, 7.3596, lower limit 999, upper 28 degrees of freedom. We have 2.579 E negative 8. So this we can say is smaller than any reasonable significance level. So since the p-value is smaller than any reasonable significance level, we reject the null hypothesis and conclude that there is strong evidence that the mean temperature, again going back to the problem and copying what the problem says, the mean temperature increase for a man with a laptop computer on his lap for an hour is above the danger threshold of 1 degree Celsius. Note again, we say there's strong evidence. We don't say for sure that this happens, but there is strong evidence. We want evidence that this is going to happen.